Okay, what you're looking at here is a relief valve test stand model GPRV, which is a relief valve calibration test stand to calibrate relief valves from 2-inch size flange valve all the way up to a 10-inch size flange valve, up to 3,000 psi with air and water. You can do an air test or air over water test. And if you had a shutoff valve like a conventional valve, you can use a hydrostatic test pump to test those up to 3,000 psi also. I'm going to go through the basics and explain to you what each individual valve engages on the control panel. Right here on the control panel, we have our air supply. We have an air supply valve and an air supply gauge. This is your shop air coming in. Your shop air is used to run your air-driven hydro pump and to run your air-actuated ball valve. Next to that, we have our water supply valve and water supply gauge. And this is your city water pressure coming in to run your hydro test and to run your air over water relief valve testing. Next to that, we have a nitrogen supply valve with the nitrogen supply gauge. And this will give you your inlet nitrogen supply, which you would use for your high pressure air tests. Below that is your tank drain. Your tank drain is for draining your surge tank. Next to that one, we have our vent valve. Our vent valve is like your drain valve, it's a vent off the test pressure. Above that, you have your nitrogen regulator, which is your test regulator, so for the high pressure air. And the gauge above that is a nitrogen discharge or your regular discharge gauge. Onto the hydrostatic station, you have your air to your hydro pump and your hydro pump regulator. This will be used for conventional valves and is not recommended to be used with relief valves. Under below that, we have our bypass valve. And our bypass valve will be explained a little bit later, but first I'll come to my supply valve. My supply valve is my isolation valve, which will isolate the whole system away from the valve you're testing. Above that's your test gauge, and you have an auxiliary digital test gauge right here. You have the two test gauges. Those are reading your pressure that's on your valve. When you bring your valve up to pressure, once it pops, you will close your supply valve here to be able to isolate your valve and to capture receipt pressure. Once you have done that, if you want to do another test, then you can come back, drain your pressure off with your vent valve, and now instead of just adjusting your spring on your relief valve, then you'll be able to open this one back up. If you open this right now, you'd be slamming whatever pressure you have in your surge tank. So you have your bypass valve to bypass this to equalize what's in the tank and what you put on your valve. Once you have that equalized, then you can go ahead and open this without damaging your valve. So now we're going to go around the back and show you your ports. Okay, so what we have below here are your test ports. I have my nitrogen inlet. This is my high pressure air coming in. My air inlet, which is my shop air, 0 to 100 psi or 0 to 8 bar. On this one would be your water inlet. This would be your city water pressure coming in. And the last one would be my drain valve. This is where we're going to be draining our air and our water from. So that one you'd have to plumb to a drain to be able to drain the pressure outside. Now we're ready to start some testing. Before we get to our testing, we're going to come here and we're looking at our clamps here. We have a sledgehammer and a sledging wrench. The sledging wrench will come with the test stand, but the hammer stays here. These are our clamps here, and you can see they have the nuts there. And you have the O-rings in the center right here where you seal your valve off of. Okay, we're ready to do a test. So we're going to do an air test that's going to pop out about 450 psi. I'm going to load the valve, tighten it down, and then I'll go and commence and do a simple air test for you. Load my valve. When loading your valve, you want to make sure you center it on the O-rings, the flange of the valve, and you want to ensure that the discharge of the valve is pointing away from you. You see, I opened up my safety shield. It's got easier access load and unload. You can load from the front or from the back or even the side. Then you bring your clamping arms, place them up on top, and snug them down. Come in here, slide them down. So I'm holding it from underneath right there, so I can be able to give them the snap. Now what we want to do is when we come in, tighten. Just hand tighten first, all the nuts. Down on there, so now I'm going to come in. Tighten down on the flange itself. Down a little loose, so back in there, hand tightening. Come around, a bit better access. Now, we're ready to do our test. Your gauge has a high peak and low peak. You want to be able to change this out. Now we're ready. Before we do anything over here, you want to make sure everything's in the closed position. You want to make sure you open both your drainage aisles tight. Make sure there's no residual pressure left in. Then you come in, turn on your shop air. Make sure you have 80 to 100 psi in here. We're going to come in, open our nitrogen supply. You want to make sure your nitrogen supply has enough pressure in there to be able to realize the test that you're about to do. We come in, open our main supply valve, our isolation valve. Both our vent valves are closed, our hydro pump will stay closed. We will never use our hydro pump when testing a relief valve. Per national board, if you're doing a water test, it needs to be air over water. So if you're using a hydro pump, the hydro pump, every time it strokes, is going to be hitting your seat. And per national board, you need to bring the pressure up constantly and slowly and smoothly. So you can't realize that type of test using a piston pump. So that's why when we go to do our water test, we will use the air over water method. Right now, we're just going to do an air test. So, we're ready to start. At the moment my relief valve pops, I'm gonna shut this valve off. I'm gonna turn the light on so I can see this better. And I'm gonna be right here. Slowly bringing up my digital gauge. At the moment that the relief valve pops, we'll go ahead and shut this out. You want to record your popping pressure and then capture your reseat pressure. Reseat pressure will be the steady state once your relief valve pops. Slowly bring the pressure up at about 140 psi right now. This should pop around between 400 and 450 psi. And now up to 200 psi. So we're about halfway there. For national board, you should be able to watch your gauge and count with it. If you can't count with your digital gauge, then that means you're bringing the pressure up too fast. I'm at 300 psi now. Now at 350 psi. It's starting to crack, so it's getting ready to pop. Once it pops, I close my supply valve. I get back off my pressure here. It popped about 372 psi, and my reseat pressure is at 316 psi. So we heard the relief valve pop, and as soon as we heard the relief valve pop, we closed this. Okay? So now, if I want to go in and adjust and redo the test again, if it popped too low, I can come in here, drain my test pressure off of my valve here now. Come in here, adjust my spring. Once my spring is adjusted, I can now come back and use my bypass, or I can open my drain valve and drain all the pressure out of my tank, or I can just drain it just enough to where I think I can equalize. I can use my bypass valve. And I'll use my bypass valve to equalize the two sides. I don't want to pop it with it, I won't have enough volume. So I equalized this. So what I did was, I got 265 psi on my digital gauge here. And so I saved some of my nitrogen. I didn't throw it all away, I didn't drain it all out. So now once it's equalized, I can come in here and open my supply valve, and I won't slam my relief valve now. Now I can continue back and go again and bring it back up to pressure. Try to pop it again. I'm at 330 psi. I'm at 360, 375. Pop. So that completes your air test. Once we're done with that, we can come in here, drain this off, want to back off the regulator all the way. Now if your test is satisfactory and you're done, now I can come in here, open my nitrogen supply, and drain all my pressure off my surge tank. and you remove my valve, and your test will be complete. Shut up. Test. Okay, we just finished doing our air test, so now what we want to do is an airable water test. We're going to use the same relief valve for this video here. And so now, both my vent valve and my tank drain valves are open. We have those open to drain all our test pressures. My regulator is backed off. My air supply is still open. My supply valve is closed. I can open my drain valves again, and sure, no pressure is coming out here or in the back. I can close those now and open. There's a little bit of air you saw there right now that was trapped into the middle of the ball. That's going to happen once you close the valve under pressure. That's showing me that your valve is not leaking. So now, what we're going to do, we're going to come in and fill our J tube that's inside here. We have a J tube inside our relief valve test stand right here. We're going to fill that with water. And we have it open on top, so that way when we see water coming out the top, we're going to close this off to ensure that we have water. Okay, so now I've opened my main water supply. When I see water at the top, I'm going to close my supply valve and I'm going to open my valve. Water just came out. So we got water on the top of the table. Come up. We're going to film this way. So now I like, unless you're using 2 people to do a test, you just have 1 person. I'm putting it sideways so I can see my water drip here. Again, for National Board, when doing a water test, you're doing an airable water. So we filled it up with water, we're going to clamp it. When testing, we're going to watch for the straight drip of water. Now you know, if it's curves back like this, that's not our popping pressure. Our popping pressure, the water has to be straight dribble with no drips, solid straight line coming down the water. That's what we're going to be looking for. Then our clamps back on, tighten them back up. Today we got our test with the low pressure that went only up to 375 psi. But the test stand can go all the way up to 3,000 psi. That pressure is going to depend on your nitrogen supply or your high pressure air. It does not have to be nitrogen, it can be a high pressure air. We use in-house here, we have our compressor over here that has a high pressure compressor that goes up to 5,000 psi. We have a regulator on that compressor to bring it down to 3,000 to test it today. The relief valve I have only goes to 400. So we have 675. Now we have our valve already filled with water, clamped in place. I have my valve mounted sideways now so I can see when my steady stream of water comes out. So I'm going to come back, open my supply valve, and if you can see my digital gauge here, I already have 102 psi of water pressure on it. Now if you're doing a relief valve that's less than that, you're going to need to shut off, once you fill it up, shut off your water supply valve. So that way it doesn't introduce no pressure in it. Or you can leave your vent valve open when you're filling. So right now I got it back down to 27 psi. We're going to leave it right there. We're going to come up now, slowly bring it up, and watch the outlet for the steady stream of water. Once I see that steady stream, I call it, I will close my supply valve to capture my receipt pressure. We're at 100 psi now. Now this is going to, you have to be a little more careful because your pressure's going to go a lot faster since you do have the J2 full of water now. I'm at 200. $275. 300 psi. On the air, we popped at about 372, 374. This might be a little bit higher than that using the water on the same valve. I'm at 330 psi. That needs to, excuse me. As you notice, I slow down when I get closer to my popping pressure. I'm at 355 psi now. 360, 365, 370, 36. So now we got that, we got it coming out, the water going back, so I'm bringing it out the middle. The water coming out, I want to get that solid stream right there. Now once you shut it off, back it off, capture the receipt pressure. Now you can record where you popped and where you receipt. And then you have your peak on here. So we got the 390 psi on our popping pressure. And then 327 on our receipt pressure. If your test is satisfactory, you can open your one drain valve to test the pressure there. If you need to adjust the spring, now would be the time to adjust it. You can come back again, like we did our air test, we used our bypass valve to bring the pressure back up to retest it. If not, you go ahead and drain down all pressures. And that includes adjusting both for air and airable water.